Assalamu alaikum. I'm Jahangir Alom, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that I'm still alright and carrying on my regular activities. Dear students, I also hope all of you are alright with your family members and carrying on your regular studies, staying at home. Right. Dear student, in our today's class, we are going to discuss a very important and realistic topic from the third chapter of physics second paper, right? That is the chapter of current electricity. Dear student, you know, to determine the electric current and resistance in a simple circuit, Ohm's law is suitable. That is, using Ohm's law we can determine the electric current and resistances. But for the complex circuit, Ohm's law is not sufficient. So, to determine electric current and resistances in a complex circuit, scientist Kirchhoffs put forward two laws. These laws are very helpful to determine electric current and resistances. Of course, Kirchhoff's law is applicable for simple circuit also, right? So, dear student, now we are going to discuss Kirchhoff's laws for the complex circuit. Okay, so let's start our today's class. Dear student, among the two laws, first we will see the first law or Kirchhoff's first law. So according to the statement of first law, they said that in any electrical network, the algebraic sum of currents meeting at a junction is always 0. For the explanation of the statement, dear student, if we consider there is a junction point, that is different wires of carrying current are connected to this point O, and different type of current, that is current with different direction are connected with this junction point. Normally the current which are coming towards the junction point is taken as positive, while the current are flowing from the junction point are taken as negative. Since here I1 is coming towards the point, so I1 is taken as positive, while I2 is flowing from the junction point, so I2 is taken as negative. In the same way, I3 is taken as positive, I4 is taken as positive, and I5 is taken as negative, because I5, the direction of the current is flowing from the junction point towards the outside, right? So dear student, according to the statement of Kirchhoff's law, in any electrical circuit or electrical network, the algebraic sum, here algebraic sum means we consider the positive or negative sign in the expression of current meeting at a junction, that is O is the junction point. All type of current is meeting towards this point is always 0. So according to this statement, we can write that I1 plus I3 plus I4, because these three currents are coming towards the junction point, so these are taken as positive, while the I2 and I3 is taken as negative, because these two current are moving or flowing out from the point. So minus I2 minus I5 is equal to 0, since they said that algebraic sum will be 0. Or we can rearrange the expression like in the simple way, I1 plus minus I2 plus I3 plus I4 plus minus I5 is equal to 0. Or in the most simple way, we can express as summation of I is equal to 0. This is the first law, this is the Kirchhoff's first law, right? So dear student, this law of this law is also known as junction law, because the statement is based on a junction of electric circuit, right? So this is all about the Kirchhoff's first law. Okay, right. Dear student, now we are going to see Kirchhoff's second law, right? Already we have seen the Kirchhoff's first law, and now we are going to see Kirchhoff's second law. It's very important and realistic, and the statement said that the total EMF within a closed circuit is equal to the algebraic sum of the product of current and respective resistance of the different branches. So dear student, it is based on a closed circuit. This second law is based on a closed circuit. That's why this second law is also known as loop law, that is Kirchhoff's loop law. Okay, so you need to keep it in your mind. So second law or loop law, their statement said that the total EMF, that is in the circuit, we consider this circuit for the better realization, it is a closed circuit because A, B, C, A, it is a closed circuit. In the closed circuit, total EMF, we use total two cell, electric cell, which one is denoted by E1 and another is denoted by E2. So total EMF of the circuit will be E1 and E2, that is algebraic sum of E1 and E2. Later on we will discuss the convention of direction of the EMF will be equal to the algebraic sum of the product of currents and respective resistances of different branches. There are three branches, one branch is denoted by A, B, then B, C, then C, A. So we need to determine the product of current. In AB branch, the current is I1. In AB branch, current is denoted by I1. In BC branch, current is denoted by I3, and AC branch current is denoted by I2. And the respective resistances. In first branch, the resistance is R1. In second branch, resistance is R3, and in third branch, resistance is R2. So dear student, according to their statement, the total EMF within a closed circuit. So in this closed circuit, total EMF will be the algebraic sum of MO E1 and E2. So dear student, here algebraic sum means someone will be positive and someone will be negative. For the better realization, we take the here the direction of the current are in the different branches are different direction, okay, in different ways. So for a better realization or conception, we take the direction of the current which are in the clockwise as positive and the direction of the current which are in the anti-clockwise as negative. But according to your requirement or your convenient, we can change the convention of the direction of law, right? So if you require or if you want, you can take the direction of the current which are in anti-clockwise as positive and which are in the clockwise as negative. It depends on you. It depends on your requirement. So for today's class, I am taking the direction of the current which are in the clockwise direction as positive and the direction of the current which are in anti-clockwise as negative. So to realize this, we can show the direction like this. This is clockwise direction. So the current which are in the clockwise, that will be taken as positive, and the current that will be in anti-clockwise, that will be taken as negative. So according to the statement, they said that total EMF. So dear student, the direction of the first cell is clockwise, here positive and the negative. The current in this cell is clockwise. So EMF of the first cell will be taken as positive, but the direction of the second cell is opposite to the first cell. So it will be taken as negative because the direction of the current cell is in the anti-clockwise direction. So first they said that total sum of the EMF. So we can take as E1 plus minus E2, right? This is the algebraic sum of the EMF in the closed circuit will be equal to the product, of the current and respective resistances of different branches. So dear student, if we consider this current in the AB branch, here the current is I1 and the respective resistance in this branch is R1. So product of current and resistance will be I1 into R1. Then if we consider the current in the BC branch, you know, here the direction of the current is also in clockwise. According to this direction, this is the direction of indicator of a clock. So here the current is moving in this way. Here is the direction. So current in the second branch is also clockwise. So it will also be positive. So plus I3 R3. And Lastly, the current in the third branch, you know, the direction of the current in the third branch is anti-clockwise, because this is the direction of clock, but this is the direction of current in the third branch, that's AC branch. So according to the convention, I2 will be negative. So we can write plus minus I2 into R2, right? So this is the mathematical expression of Kirchhoff's second law. Okay, so dear student, we can write also the expression like this, or E1 minus E2 is equal to I1 R1 plus minus I2 R2 plus I3 R3, right? Or in simple way, we can write summation of electromotive force means E equal to summation of the product of current and respective resistance. So dear student, this is all about the Kirchhoff's second law, and it is very important. It is very important to determine electric current and resistances in a complex circuit, right? I hope you got it, and you need to memorize the statement, and you need to realize the situation or convention of direction of current and electromotive force, right, dear student? So it is very important for your upcoming exam. Now we are going to solve some mathematical problem that is especially based on a closed circuit. Okay, we are going to determine electric current and resistance from a closed circuit, which is right. Dear student, you can see here is a complex electric circuit. So different type of resistance, electric cells and electric current are shown in the circuit. Their question is determine the currents in different branches. So from this complex circuit we need to determine the currents in the different circuits, or simply the question may be appear like this, find the values of I1, I2 and I3, because in different branches the currents are indicated by I1, I2 and I3. So determine these currents from the circuit. Now we are going to use Kirchhoff's law. So dear student, you know there are two laws put forward by Kirchhoff. So first we apply Kirchhoff's first law at point E, because here is a junction. Current I1 is coming to this point E, I2 is coming to this point E, and I3, the current which is flowing out from the point E. So if we apply first law at point E, then it will be I1 plus I2 minus I3 will be 0, right? So dear student, according to first law at E, if we apply the first law at point E, then the current that are coming towards the point E will be considered as positive. So it will be I1 plus I2 and the current I3 which is flowing out from the point E. So it will be negative I3 is equal to 0. This is equation number 1, right? So dear student, you know there are three variables. The value of I1, I2 and I3 all are unknown. So there are three variables in the equation. To solve this type of equation, you know at least three equations are required to solve this type of equation. Since there are three variables, so we need at least three equations. So one is we established according to first law. Now we are going to establish another equation in this loop, that is in the loop B, E, C, D. So in the loop B, E, D, C, B, we apply second law or loop law in this closed portion or in this closed circuit. So dear student, according to the convention of direction of current, we will consider the direction of the current which are in the clockwise, that are positive, and the current which are in the anti-clockwise as negative, okay, as well as the direction of electromotive force. So in B, E, D, C, B, according to loop law, or second law, we can write that student, you know, so current in the first branch ED is I3, and the BE branch it is I2, and CD branch is also I3, and finally CB branch is also I3, because I3 is coming through this point, okay. So if we start from this point, or for the branch here, the current is I2 and resistance is 20 ohm. This direction of the current is clockwise. This direction of the current is clockwise, so it will be taken as positive. So we can write I2 into 20, that is 20 I2. Then here the direction of the current is also clockwise, so it will also taken as positive. Here the resistance is 8 and the current is I3, so we can write 8 into I3. Then in the third resistance, that is which is denoted by 12, so current through this 12 ohm is also in clockwise direction, so it will be positive, so 12 I3. And lastly, that amount of current, that is I3, is also will pass through the resistance 4 ohm, okay. So it will be taken as 4 I3 will be equal to the algebraic sum of the electromotive force. So dear student, you know, here this end is positive and this is negative, this is positive, this is negative, this is negative, this is positive. So according to the convention, so direction of this cell is positive, that is it is clockwise. It is anti-clockwise, it is anti-clockwise, so we can write equal to 10. It is positive because here the current is clockwise direction, so we will add 4, but the direction of this cell is, the positive end is, according to the convention, it will be negative, so it will be -2. So dear student, if we simplify the equation, 20 I2 plus 24 I3 equal to 12. If we simplify the equation, that is dividing both sides by 4, you will get 5 I2 plus 6 I3 is equal to 3. This is equation number 2. So that we have got only 2 equations. We need one more equation to solve this type of equation, right? So now we will apply loop law or second law in this loop, right? And for our convenient, we take the direction in this loop in anti-clockwise. So the current in the loop that are in anti-clockwise will be taken as positive, and the current in the loop that are in the clockwise will be taken as negative, right? So in BEFAB loop, right? So there is shown here current I2 and resistance is 20 ohm, so it will be 20 I2. In the branch EF there is no resistance, but in FA branch there is a resistance, so here current I1, this is also applicable for the branch AF or FA. So and here the current is clockwise direction, so opposite to the convention. So here the current will be negative, that is minus 10 I1, right? Okay, so there are no resistance in the third branch, so it will be the algebraic sum of the electromotive force. Here the direction of the cell or direction of the current in the cell is anti-clockwise, so it will be positive, so it is 10, but direction in the cell is negative according to the first one, so it will be minus 5, and the electromotive force in the cell, that is 1 volt, so it will be minus 1, right? So after simplification you will get 20 I2 minus 10 I1 is equal to 4. Or after simplification, if we divide the equation by 2, you will get 10 I2 minus 5 I1 equal to 2. Now we are going to use the value of I1 from the equation 1. If we use the value of I1 from the equation in this equation, they will get, so 10 I2 minus 5, that's, you know, value of I1 will be I3 minus I2, so I3 minus I2 will be 2, and after the calculation you will get 10 I2 minus 5 I3 plus 5 I2 is equal to 2. Okay. Okay, so after the calculation you will get, therefore 10 I2 plus 5 I2, that is 15 I2 minus 5 I3 will be 2. This is equation number 3. Yes, now already we have got 3 equation, equation 1, equation 2 and equation 3. So using this 3 equation we will be able to determine the value of I1, I2 and I3. Okay, so dear student, using this 3 equation, now we are going to get the value of I1, I2 and I3. First we need to compare these 2 equations. There are 2 variables I1, I2 and I3 in both the equation. So to make the coefficient equal in these 2 equation of I2, if we multiplied equation 2 by 3, then the coefficient will be equal. So we will be able to omit one of the variable from these 2 equation. So multiplying equation 2 by 3, then we will divide subtract equation 3 from the product. So their coefficient will be same. So in that case 18 plus 5, 23 I3 will be 9 minus 2, 7, or I3 will be 7 divided by 23 ampere. So this is the value of I3, that is the current or value of I3 is 7 by 23 ampere. Now we are going to use the value of I3 in equation 2. We use the value of I3 in equation 2. Therefore 5 I2 plus 6 into I3. I3 means 7 divided by 23 is equal to 3, or 5 I2 is equal to 3 minus, it will be 6 7s are 42 divided by 23, and after the calculation you will get, it will be 69 minus 42, 27 divided by 23, right? Therefore the value of I2 is equal to 27 divided by 23 multiplied by 5. So it will be 27 by 115, right, ampere. So this is the value of I2. So I1, I2 and I3 are already determined. Now we need to determine the value of I1. So dear students, now we are going to use the value of I2 and I3 in the first equation. Okay, right. So from equation 1, I1 plus I2. I2 means 27 divided by 115 minus I3 means 7 divided by 23 is equal to 0, or I1 is equal to 7 divided by 23 minus 27 by 115, right, or the LCM will be 115. If we divide 115 by 23, it will be 5 multiplied by 7, 35 minus 27. So after the calculation, you will get 8 divided by 115. So this is the value of I1, right? So dear student, I hope you got it. So value of I1 is 8 by 115 ampere. Value of I2 already you have obtained 27 by 115 ampere, and value of I3 that we have got in first 7 divided by 23 ampere. So these are the required value for this question. So dear student, I hope you got it, but for better realization you need to practice this type of problem from your textbook. But if you have any confusion, you can ask me or you can ask your subject teacher. Okay, so many good wishes for all of you. May Allah bless all of you. Assalamu alaikum.